one, which we call it as your Ethernet and your internet protocol addresses. As we discussed, there will be three addresses. One is your transport layer address, we called the port address. Okay, and we have the next one is your internet layer protocol, or we call the network layer protocol. We call them as your internet protocol address, that version 4 or version 6. And the data link layer protocol, we call them as your MAC addresses. MAC address or physical address or Ethernet address. So different terms are used for this. Okay, so we'll see this one by one. In the Ethernet and Internet protocol, what we are going to discuss in this, we are going to cover what is Ethernet, what is the format of your IPv4, IP addressing basics, types of IP addresses and default gateway, and we'll little bit try to cover the IPv6. We don't want to go in detail in that, but the material will be given to you. You can, if you want to go for more understanding, you go through the material. But we are going to discuss the basic addressings which are needed for our course, for this course. Okay, so in this, Ethernet is the first one, the lower layer network address. So this Ethernet encapsulation or Ethernet addressing, unlike the wireless, this Ethernet uses a wired communication that includes the twisted pair, your fiber optics links and coaxial cables. 1, your 2 and 3. Twisted pairs, fiber optics links and coaxial cables are used. So this Ethernet operates by which layer? Your data link layer. So this data link layer is divided into two parts. One is logical link control and your MAC address. Logical link control and your MAC address. So this Ethernet operates in the data link layer and your physical layer as said. So it is a family of your network technologies defined the standard IEEE 802.2 and 802.3. These standard technologies are referred to the Ethernet. Unlike your wireless. For wireless, different IEEE technology uses. Okay, so for logical link control, 802.2 technology is used. For MAC address and bit streaming, the 802.3 is used for the Ethernet. So this Ethernet supports the data bandwidth from 10 megabits per second to your, the 100,000 megabits per second, or we call the 100 GB, 100 gigabits per second. So it is the capability of your Ethernet. Okay. So this Ethernet uses, as we said, it is divided into two parts. So the first part, that is logical link control part, this sublayer is used to generate the frames or build the frames from your packets. When the packets are received from your network layer by this data link layer, the logical link control convert those packets into frames by adding frame header and frame trailer. Okay, and these frames will be passed through within the private network by using a MAC address. Okay, so first the upper sublayer of your data link layer generates the frames. Lower sublayer is used for routing the packets within private network. Okay? So this you can see in the frame. as we discussed, the frame Ethernet frame fields, it is having frame header and frame tailer. Correct? So in this frame header, the size of this is lies in between 64 bytes to 1518 bytes. So the minimum Ethernet frame size is 64 bytes and maximum is 1518 bytes. So which includes the all bytes from your destination MAC address field through your frame check sequence. In the frame check sequence is used for the whether the frames are received correctly or not. During the transmission, there may be the frames may be damaged. So on the receiver side, they use the same frame check sequence to check whether bit sequence is correct or not. So in this, what will be there? The first 8 bits, the first 8 bytes, used for preamble and the SFD. We call this as the synchronization frame delimiter. So by using this, it alerts the receiver that the frames are coming now. Okay, and after that 6 bytes used for your destination MAC address. So every destination having their physical address, so destination MAC address, and 6 bytes used for source MAC address, sender's MAC address, physical address, and 2 bytes used what type of message it is, 2 bytes, and what type of message means whether it is a web message, web browser, or whether it is a FTP message, whether it is a HTTP message, which application message it is, that describes. And then the next 46 to 1500 bytes used for your data. So maximum size of your frame is your 1518 bytes. Okay, and last 4 bytes used for your frame check the sequence. So this is the Ethernet frame field. Okay, first 8 bytes for preamble and last 4 bytes for frame checking. Okay, so source address, destination address, then what type of that message it is, and what is the data, when to check whether data is received correctly or not. Okay. So in this, as said, the preamble are your start frame delimiters, the first 8 bits. So they use to synchronize between sender and receiver devices. That means if sender is able to send 1 GB data, receiver is able to receive 1 GB data or not. Synchronize it, same speed. If sender is sending, suppose 5 Mbps, suppose, the receiver also, sender and receiver also able to receive the same 5 Mbps, megabytes per second. But instead of that, if receiver is able to receive only suppose 3 Mbps, but sender is sending 5 Mbps, remaining 2 Mbps will be dropped at the receiver side. So that means these 2 Mbps data pieces are dropping. So again those 2 Mbps of data again retransmit to your receiver. So to avoid this problem, the preamble or the start frame delimiter synchronize. I want to send 5 Mbps. Are you able to receive 5 Mbps or not? If says okay, then sender will able to send 5 Mbps. If the receiver says no, you send only 3 Mbps, then your sender will try to send only 3 Mbps instead of 5 Mbps. So that is the synchronization between sender and the receiver. So that's why the first 8 bytes are used for the preamble as your start frame. Then the destination address, MAC address, as said, the physical address, and source MAC address, source and destination to identify each other. Okay. Then type or length that gives the identify the upper layer protocol encapsulated in the Ethernet frame. And data field contains the encapsulated data, and frame check sequence is used to detect the errors, whether the frames are received correctly or not. So one method which is used is your cyclic redundancy check, or your odd parity or even parity checks are also used here. But most the frames they use the cyclic redundancy check, because if you have a bit stream that on sender side, sender is sending a bit stream of 0 1 0 1 1 1 1 0 suppose, and when it is going through the path, and somewhere because of some jerk in the path, this bit stream may change from your 0 1 0 1, then 0 0 1 0. So these are corrupted bits that will be received by your receiver, this frame size. So then whatever this CRC is there, this CRC checks whether these bits are corrupted or not. If corrupted, which bits are corrupted, whether these two bits or these two bits or these two bits or these two bits. So that will be corrected by the method of your cyclic redundancy check. Okay. So that is the useful way of your frame. So these bit corruption, it can happen either because of your the hardware problem or because of your attacker problem. If attacker are there, they may change bit, right? If they change the bit, means bit is it is modified, altered. Then by using this CRC on receiver side, they try to correct those bits and use. If they are unable to correct by using CRC, then ask the sender to resend the same message. Okay, so that is the address which is used. We call the MAC address, source address and destination MAC addresses, or we call the physical addresses. So this MAC address format is, it uses the 48-bit binary value expressed as 12 hexadecimals. Expressed as 12 hexadecimals. What is the size of MAC address? Actually 48 bits. When it represents in the hexadecimal format, it uses the 12 hexadecimal digits. Okay. So how, if you see the conversion of your binary, decimal to binary, binary to hexadecimal, you can find that the decimals we can write, from 0 to 15. Hexa means 16, right? So from decimal we are taking from 0 to 15. So it gives total 16. So 0 0. So total 16 is there. We can write 2 to the power of 4 is equal to 16. Correct? Correct? So every decimal number can represent with 4 bits in terms of binary. So in the binary you can find 4 bits are there. So 0 0 0 means it represents 0. 0 0 1 is 1. 0 1 0 is 2. So like that, the binary, if all ones are there, means it is 15. Then this binary is converted into a hexadecimal, as decimal means it uses the numbers from 0 to 9, right? 0 1 2 3 4 5 6 7 8 and 9. Total how many digits if you count? 10. So that's why we call them as decimals. Hexadecimal means 16, right? So the 11, the 10 is represented with capital A, 11 represented with capital B, 12 represented with C, 13 represented with D, 14 represented with E, and 15 represented with F. So here you can see the 10 is represented with A and it goes on. So these 48 bits, okay, represented in the hexadecimal format. So it takes 12 hexadecimal digits. 12 hexadecimal digits. Is that correct? If you divide 48 by your 12, how much it takes? 4 bits, right? Okay. So every 4 binary bits converted into one hexadecimal. So that's why to represent 48 bits in hexa, it takes only 12 bits. Because 12 into 4, it is 48. So every 4 bits represent one hexadecimal. So that is the translation. You can see decimal to binary, binary to your hexa. So it takes 12. So if you have the 48-bit binary value, that can be represented with 12 bits. So here, let us see this. They can be, this hexadecimal can be represented in the form of your with the dashes or with the colons or with the periods also. So if uses the dashes, it uses 2 bits. Total 16 bits. So what this, its equivalent binary is equal to what? 0 0 0 for the first 0 and 0 0 0 for the next 0. For 6, what is the value for 6? Your 0 1 1 0, and for 0 it is 0 0 0 0. Similarly, if you start writing for all these, you will get 48 bits. Okay, so this is the MAC address format. And the next one is, the next IP address is, next address in the network is your Internet Protocol address or IP address we call. Okay, so there are 2 versions are there, IPv4 and IP version 6. But we will focus on only IPv4. We will ignore this, but for your study purpose, this information, this lecture content is also provided. If you have time, you just go through that. Okay. So with this, I would like to stop this session here.